So I'm really happy to be here. My name is Terrell Carrasco. I'm president of Valhalla Private Capital. We're a corporate finance and angel investment firm. We have been investing in tech before it was sexy to invest in tech. We've been doing it for about 25 years, where it started in the Calgary Petroleum Club, where a couple of oil and gas guys were looking at some software. We thought we threw some capital at them, and it's emerged and become quite a thing since then. I've learned a lot so far, especially around the policy conversations that have been happening. I've been sending notes back to our investment team, like I'm learning a lot about the microgrids and all that stuff, and the lens of an investor is quite different from the policy conversations. But we base a lot of our thesis on research that's done. Right? When we start looking at the economics of a deal, we have to start from somewhere. We have to start from government research, from large corporations initiating large projects. And all of that forms the basis for our research, that when we start baselining opportunities to invest in companies, we have to have that data from somewhere to understand where it makes a lot of sense. And guess what, guys? It's starting to make a lot of sense. The economics are starting to make a lot of sense. And as investors, we're not looking anymore to solely government or large corporations to make multi-billion-dollar investments that maybe we'll see commercialization in 25, 30 years. But we're now starting to see emerging companies that are deploying small-scale capital, where we can see a return in 7 to 10 years. And for a private investor, that's very interesting for us. And we're excited to be part of that. And going back to the economics. So what does an investor look at? Well, we look at a number of different things, right? And we had a quick meeting with the judges here. We look at the team, we look at the market opportunity, we look at scalability. Canada is doing really, really well at launching small-scale companies. We're struggling on scaling these companies. And what's needed in the industry, in decentralized energy, is risk capital. Risk capital that really takes us to the next level. I have some news for you, and we're in Ottawa. Government will not be the driver of innovation and growth in this industry. Okay, it will be private capital. It'll be individuals like myself, large corporations that we're going to deploy risk capital to really scale. Why? Because it's important. There's an ethical and social reason for doing this. But over and above that, investors don't solely look at the ethical and social reasons. We look at bottom line. And I've been involved. I listen to pitches every month. There's approximately 50 to 60 companies that apply to pitch to me, through our investment committee. And the things that we ask: great social impact, awesome benefit of society. Those are important things. Great team, great technology, disruptive market. All of that is great. But then the last thing they ask is, when do I get my money back? And that's the bottom line. We live in a capitalist system, and maybe I would say, I was actually talking with one of our analysts, like about 5 or 6 years ago, maybe 7 years ago, that was a challenging answer, because the event horizon, or the liquidity event, as what we call it in the industry, was projected way out. But now an entrepreneur can say, through an acquisition, through IPO, through a merger, through whatever we call a liquidity event, is when the capital is returned back to the investor. That can now happen between 5 to 7 years. That's incredible. That's an incredible thing. But I'm going to issue a challenge now with all the folks here that have been talking about policy. We need to enhance that economic conversation. We need to really encourage small-scale startups and entrepreneurs to start taking risk and launching companies. There is capital sitting on the sidelines that wants to deploy that to amazing companies. And I would encourage all of us to engage in that conversation. And I'm happy to entertain the hows and the whys after. This is the future: private capital to fund transition, the largest industrial economic transition that Canada is going to embark on will be funded also with private capital, and with public capital as well. But private capital is what's going to fuel that growth and create those market opportunities globally. So with that, I think I've spoken already for maybe 7 to 10 minutes. I don't even time myself, but we'll now transition. We'll invite the founders to come up to the stage, to the firing line. Come on up. Let's get a round of applause for our founders and entrepreneurs.
Well, good afternoon. I'm Mark Chidwick with Enermetrics, and I've been working in the energy industry for over 35 years, and I saw the writing on the wall and decided to move into to clean tech. So as we know, the drive to net zero is absolutely huge. Our buildings play a big role in this, with 27% of our global emissions, and across Canada, we have 6.3 million commercial facilities that need energy upgrades if we're going to meet our targets. There's a common misconception that electrifying everything is going to solve our problems, and it actually won't, at least not until our grids become clean, and that's going to take some time. But there's also many technologies that we can now consider. There's an awful lot of innovation in the market, and it's not like we have a choice, right? Whether it's through legislation or whether it's through social pressure, all of these buildings are going to need to have a plan. But creating this energy plan is actually impossible with today's tools. Current tools are inaccurate because they use monthly or daily averages, and they're very manual and time-consuming and expensive. Imagine you have 100 hotels and you'd like to create an energy plan for these. There's dozens of technologies that you need to consider for each one of those hotels. And with the current tools, this would cost hundreds of thousands of dollars. Okay. Okay, so we're good. Okay, imagine you have 100 hotels. You'd like to create an energy plan and reduce the energy costs and emissions. There's dozens of different technologies. With the current tools, this is going to cost hundreds of thousands of dollars to develop. What the market actually needs is the ability to assess dozens of technologies across a portfolio of buildings and do so efficiently and accurately. So let me demonstrate this with a quick example. With today's tools that don't work very well. A ski resort engaged an engineering firm to find ways of reducing energy costs. They modeled a combined heat and power, or CHP, solution and determined it had very poor performance. But they were using monthly averages and didn't take into account the large seasonal electricity demands for snowmaking, as you can see on the top chart. We took this into account and using the hourly data and found, in fact, that 3 CHPs provided significant energy cost reduction because it took that peak demand into account. And as you can see, this went from a very bad idea to a very good idea. And this demonstrates that the details are important. We have 3 advantages over our competition. First of all, we use detailed hourly data versus the monthly averages. Second, we can process thousands of buildings and dozens of technologies all at the same time through automation. And third, our financial risk analysis allows for complexity in forecasting. So here's how it works. First, we upload the information about a portfolio of buildings, including the location, the meter data, and the facility type. Oops, didn't work. Okay, next we simulate hundreds of combinations of technologies, taking into account the market variables such as the energy cost, the weather data, technology performance factors, grid emission intensity factors, as well as the detailed hourly information. And this results in a very large number of potential solutions, and all of this is done automatically. Finally, we need to compare the financial and environmental performance for each of these projects and filter out those projects that have they're best aligned with our objectives. Once the project is identified, an assessment of the risks is needed. And traditionally, energy consultants will assume a fixed forecast rates for your natural gas rates, electricity rates, carbon taxes, carbon intensity factors, and so on. But these predictions are usually way off. So our software simulates a range of different technology outcomes and how each would affect the key risk factors. And this enables the CFO to make a more informed business decision. We have a working desktop tool that is used for deep interactive analysis. We have now completed an API, which enables us to integrate with data holders such as utilities and energy management software companies. And the self-serve search engine platform is currently being built and will provide the building owners with the ability to assess a wide range of different technologies. Our current revenue has come from pilot projects, and some examples are shown here. This has provided us with the opportunity to develop and mature our platform over the past years. But now it's time to scale up and to help the building owners accelerate the development of their clean tech projects. We have a great team. Floyd has a background in founding and growing tech companies. I am the technology and industry expert and the primary coder of our platform. Marine is a serial entrepreneur with a background in both software and clean tech. So far, our revenue has been based on consulting for energy and carbon strategies. We have many repeat customers. We have completed our recommendation engine as well as the API. We have interest from engineering firms and data holders for our API offering, and we will complete our search engine offering by Q1. Then we're going to validate the traction with the API market in late Q1 or early Q2, and we expect to establish relationships with the engineering firms and the data holders. All of this is then going to be leading to support a seed round in Q2 2023. Our priority right now is to develop strategic partners with those data holders and utilities, as well as the portfolio managers. And with that, I got 1 minute left and ready for questions. Yeah, so the ideal customer is a building owner operator. So hotels is a good example, grocery stores, senior centers, high density housing, not condos. Don't want to deal with condo blokes. Institutions, the industrial clients that are really concerned about resilience, right? So they have to be continue operations even in the event of a grid failure. These are all good examples of organizations that would be interested.
Yeah. So I have a question around your competitive edge. So you talk about hourly data and then taking multiple technologies. So to have a competitive edge in the industry, are you looking at, is there any intelligence involved in your optimization process? Or like if your competitor shoots hourly data, what would be your competitive edge? Is there any intelligence involved?
Yeah, good. I'm the, by the way, I'm the CTO. The CEO should be here, wasn't available. But that's the technical question. So good. Our competitive advantage, yeah, we use hourly data. We use hourly data. Could our competition also use hourly data? They would have to refactor their platforms very significantly. Problem with using hourly data is just a ton of it. And so we did, in the early days, decided that it was really important because it takes into account the really big peak swings in power, and that makes a huge difference to the economics. Right? The other part of what we've done is we've implemented what we call a playlist. So in other words, here's a bunch of technologies that work well together. Now I did a project for 2,100 hotels across the US. And we said, okay, here is the energy data for 2,100 hotels. And I ran it across the playlist, and that took 2-3 hours. Right, so it automates the generation of a great deal of potential solutions. Most of them are garbage, but that's where we can come in and sort through and say, well, let's throw out all the garbage. Let's find the ones that are really juicy. I would see our pre-seed round, once we get some validation from the market on our API offering and have some signed customers, somewhere between 2 and 3 million.
All right. Thank you very much.
Hydron is commercializing the world's most cost-competitive and effective clean gas refining system. Not just for traditional utility scale applications, this system will promote distributed RNG and clean hydrogen production and utilization, the very fact or the very theme of this conference. Hello, I'm Perry Toms. I'm the Senior VP Corporate Development of Hydron Energy, and here's why size matters. Well, no one here needs convincing of threats. Nope, it's not. Yep, there we go. No one here needs convincing of the threats and risks of climate change. Looking at the required reductions to meet the 2050 targets at this space time looks both immense and urgent, and dare I say nigh on impossible. The good news, 60% of the required decline in fossil emissions will come from technologies that already exist today. For instance, the declining cost of renewable generation and batteries will assist in the decarbonization of the energy sector at a lower cost than seemed ever possible 10 years ago. And this will affect the residential heating and lighting, as well as light commercial and personal transport. However, that leaves the challenge for decarbonizing the hard-to-abate sectors of the economy, where electrification will either be impossible, more complex, or significantly more expensive. These are the heavy industries like steel, cement, chemicals, minerals, and transportation such as shipping, aviation, railway, and long-distance road transport. Heavy emitters in these sectors currently account for 25% of CO2 emissions, and with changing statistics and growth in these sectors, they could represent 50% in the next 10 years if no action is taken. The good news is that alternative fuels and technologies, again, many available today, make it technically possible to achieve zero emissions in each of those sectors. But they too come along with challenges and barriers, and this is where Hydron comes in. Conventional approaches to dirty gas cleanup are capital intensive, require massive energy inputs, and are constrained by location, infrastructure, and feedstock availability. Hydron Energy is addressing those inherent shortcomings by commercializing the smallest scale, cost-competitive gas refining technology on the market, designed to efficiently strip pre-combustion CO2 and other impurities from processed gas streams. The interrupter system creates low carbon, carbon neutral, and carbon negative fuels compatible with existing distribution infrastructure and, most importantly, end market requirements. The interrupter system is enabling technology that many existing players can broadly deploy to refine dirty gaseous fuels and create low carbon energy and valuable gaseous or liquid products. Interrupters significantly improves the economics of renewable natural gas, blue and turquoise hydrogen, green ammonia, which we haven't talked about yet, but I'd be happy to do so, carbon capture or CO2 capture and utilization. One system, unlimited opportunities. The interrupter plant is half the size of a conventional gas cleanup system while producing clean fuels for much less. In addition to its proprietary core components and design, provides significant savings and better carbon intensity scores. High efficiency, a small footprint with lower capital and operating costs means interrupter scale to match the feedstock from various sources, whether that's an on-farm anaerobic digester, a municipal wastewater treatment plant, to future on-site fueling stations or onboard hydrogen purification for large transports such as ships. Hydron is commercializing 2 versions of the interrupter system in the coming months. We will deploy a low-cost biogas upgrading solution to produce renewable natural gas, and shortly thereafter, a blue and turquoise hydrogen purification system. The company designs, manufactures, builds the proprietary components with interrupter, core module, but we rely on established strategic alliances and partnerships to supply the balance of plant and co-develop applications and projects. Hydron will be initially offering 3 biogas upgrading solutions with plant sizes that best fit the size and scope of the project. Our market penetration point will be small scale, 20 to 200 cubic meters per hour plants for customers who want affordable devices for low production volumes. Larger projects can easily be scaled using the inherent design for large RNG or blue hydrogen projects. The growth of the biogas to RNG and blue hydrogen industries is driven both by regulatory pressures and industry commitments to environmental and diversification goals. However, the high capital cost of current systems make small projects and this idea of distributed energy often too expensive. A low-cost, high-efficiency, scalable product is in high demand by the RNG market. Overcoming the scale-related barriers is critical to RNG achieving its full potential as a clean energy and methane abatement solution. Hydron's strategy is to meet this demand through our design. Hydron is a new company, but we're not a startup. Sohail Kahavi, the current CEO and CTO, has 30 years of experience and built the company now known as Savante, one of the leaders in carbon capture. We're leveraging Sohail's career as well as the experience of the technical team who have all worked together over the course of the last 10 years. Hydron's unique strength is its specialized technical expertise, with half our team holding postgraduate degrees. This team brings relentless passion, quick learning to our culture of innovation. The company's strategy is built around developing strategic alliances, partnerships with organizations that offer expertise and quickly commercial opportunities. Given the time, I think I'll just skip to the end. We've raised about $5 million so far in our seed round, including $1 million of non-dilutive capital. We're going to raise approximately $20 million in 2023 in a Series A, market conditions permitting. And Hydron is just getting started. We're helping create the clean fuel for the future of heavy industry and transportation. With progressive scalability, low carbon footprint, and superior project economics, Hydron's interrupter system will unlock many net zero fuel sources for producers and users alike. Thank you very much for your time and attention. I look forward to having you participate in our exciting future. Yeah.
So you're doing a seed angel round of $4 million. And
No, we've done that. That's
done
closed. We just closed that last week.
Close that.
Yeah.
Okay. So and then you're working towards a Series A,
USD 20 million.
USD $20 million.
Yeah.
On what valuation then?
Well, that will be negotiated with our investment bankers, but I'm shooting for a $75 to $100 million valuation.
Okay. Can you tell me where your revenue's at?
We're pre-revenue.
Your pre-revenue. Okay. Excellent. Thank you.
Okay.
That's it. We'll move to the next one. Thank you
Great.
very much. Great job. Excellent.
All right. Good afternoon. I'm Dr. Brennan Gantner, CEO and co-founder of Skip Technology. So climate change here. It's a problem. But at least in the energy sector, we have a solution, and that's renewable energies. Unfortunately, renewable energies are both the solution and the problem that we're trying to solve. And that kind of leads into what makes carbon fuel so great. In many respects, they've been around, their legacy, but I would contend it's their ability to travel through time that's the carbon's killer app. Wind and solar, it produces energy when it wants. Carbon fuels, we can control it. It sat around for 100 million years. It doesn't care if it waits another month, another 5 minutes, another 30 seconds for us to balance the grid. We have to give that computational advantage to renewable energies if we're ever going to get carbon completely out of our grid. And, oops, come on, there it goes. So that's the opportunity we've got. It's the problem, that's the market that we're going to solve. And I can talk about this is going to be $1 billion market in energy storage. It's going to be many billions. It's going to go up. It's going to grow. I can show you the pretty graphs. But I think the best antidote you can walk away with is the Koch brothers, the kings of coal, who we all know give two hoots about the environment, are dumping hundreds of millions of dollars into energy storage. Even they see where the wind is blowing on this one. So you know, if they're doing it, the financial opportunity is there. All right, so what are we doing at Skip? We want to make utility scale energy storage batteries out of hydrogen and bromine. These are two inexpensive electrolytes, and we're going to put them together in what's called a flow battery. Basically, you have big tanks of chemicals. You mix those chemicals together, you get electricity out. When you want to recharge the battery, you simply put the pumps in the other direction, you put electricity back in, and you split into your two original chemicals. It's a closed cycle system. We're not burning anything. We're not refilling it. It's a battery just like you're used to with a lithium battery. Now, these chemicals and these batteries have been around for 40 years, and people have tried to commercialize them numerous times over those 40 years. And the reason they keep failing is because at the heart of the battery, there's a very thin membrane. Basically, you have to bring the chemicals together, allow them to exchange protons, but not physically touch. That shorts the circuit. And that membrane has always been the flaw of these batteries. It has to be physically strong. It has to last for 20 years. It has to be cheap. It has to be anti-corrosion. All these different requirements. No one's been able to solve that. That's what Skip Technology has done. We have solved that problem by replacing that physical membrane with what we call a liquid membrane, a flowing sheet of liquid that continually refreshes itself. That's going to unlock this technology and allow us to go to market. Now, this liquid membrane actually has more advantages over the solid one than even just fulfilling its basic requirements. It's robust, it's inexpensive, it'll last longer, it's cheaper. I can make it with a 3D printer in my garage right now. And it's a drop-in replacement technology. We're taking 40 years of experience off the shelf, we're fixing the flaw, and we can get to market faster than anyone else. And that unlocks HBR batteries. These flow batteries, they have independent power and energy. We can tune our batteries to what the customer wants. That makes them cheaper in the long run. You're not fixed in how much power and energy you deliver. And they get cheaper as they get bigger. You keep scaling these batteries, every unit of energy you store gets cheaper than the unit before it. So here's a real quick just view. This is what a liquid membrane cell looks like. These are on a tabletop. If you want to go see the video, you can go to our website. I won't run it here because it actually takes a while. But basically, we started off at a square millimeter, and now we're up to 10,000 square millimeters just a few years later. We've reached commercial scale. This is basically like an individual piston in an engine. Right now, we've got an individual piston. Our next step is to actually combine these into a block, not because it's a new technology, just because we want to manufacture them faster. All right, so this is our vision. We start out, we build these into shipping containers. Flow batteries work better the bigger you make them. So you give me a 20-foot shipping container, I can run about 33 homes off of that. You give me a field of shipping containers, 3 or 4 football pitches at the edge of town, I can run a major city off of that, something the size of Seattle, off of just a few hundred containers. You give me a factory-sized battery, these don't have to be just constrained to containers. You give me a factory, I can run the largest cities in the world off of these batteries. We can take the equivalent of the entire state of California, every car in California off the road with one of these factories. So our team, we were founded by myself and my best friend, Ben Brown. We were roommates in grad school. We've known each other for 25 years now. The basic breakdown is he's the dreamer. I'm the guy that actually has to try to build whatever he dreams up. We've got a great CFO. He's a retired investment banker. And our lead scientist is a world-class expert in corrosion and ceramic materials. So as I said, I've been working on this for almost a decade now. I approached this as how I was going to make a difference with my career. And we've been developing this for about 8 years, this specific solution. We've taken it from a single square millimeter all the way up to, as I said, 10,000 square millimeters now. We've reached commercial scale. We've reached our commercial power targets, and we're looking to take this into the next step. We've been funded to date by a combination of private investment and government grants, and we're in the middle of actually our Series A right now. So we're looking at raising about $20 million US. And what we're going to do with that, as I said, we're going to take a single cell and we're going to learn how to manufacture it at scale. We want to take that, break it into the engine. We put that inside a shipping container with tanks, pumps, and we're going to have a functional battery faster than any of our competitors on the scale of 18 to 24 months. So we want to have a pilot project in the field storing energy. We've already got customers lined up, and we've got an entire suite of markets all the way from selling one of these batteries all the way up to the dream of selling to utilities at hundreds or even thousands of batteries at a time. And yeah, actually, I'm going to stop it there just based on my time. Thank you very much.
I have a question about the technology.
Yeah.
Right? Most batteries, the advantages around the energy to power ratio, like the charging duration. So how long is your charging duration or your energy to power ratio?
So that's a great thing about flow batteries is you can actually balance the power and the energy are independent. It's again, much like a car. You can have an engine and a gas tank. I can make a funny car with a huge engine and a minuscule gas tank, or the complete opposite of a Honda Civic that has a minuscule engine and a huge tank. So the rate at which you charge is entirely dependent on the power, how big you want to make that engine. And so we can customize that to whatever the customer wants. If you want to be able to suck in power as fast as you possibly can, we're going to have a lot of engine. If you have the ability to trickle charge, so to speak, and that transition can be slower, we can have a much smaller engine saving you a lot of money. So it actually is, that's a completely dependent answer on what do you want? I can provide it.
Hi, my name is Natasha Kostanek, and I'm the founder and CEO of Ayrton Energy. We're developing EV charging and energy storage powered by hydrogen. Last summer, I met a woman who complained she couldn't charge her Tesla and run her air conditioner in her home at the same time. And as an engineer, I didn't think that problem really existed. So I did some research, I was curious, and I discovered that she was right. Our electric infrastructure was not built for the electrify everything shift happening today. Almost 80% of this infrastructure was built before the year 2000, and upgrading the infrastructure is very expensive. In addition, there are a growing number of brownouts and supply restrictions, including concerning reports of consumers being locked out of their energy devices during peak demand. When you look at where the grid strain is seen most, you see California and Texas have the most power outages, and these power outages are growing dramatically over the last 20 years. Energy security concerns are growing with them. These challenges are not only happening in the US, but also here in Canada. In fact, we had grid alerts in Alberta only a few weeks ago. There was also recently news from Colorado that customers were locked out of their thermostats during a heat wave. Customers were very upset, to say the least, to lose control of their energy when they needed it most. We all know that EV adoption is growing, which will continue to add strain to the grid distribution system. For example, when even 30% of us have EVs, we will need more than a handful of chargers in each parking lot, and the grid cannot handle adding these chargers. Off-grid energy generation will be needed to augment the energy from the grid. Ayrton is developing the EDIF, a hydrogen-powered energy generation system. It can be used for EV charging for single vehicles or small fleets, and the system can also provide short-term backup energy in the case of an energy disruption. Hydrogen-powered EV charging will, of course, require hydrogen to be safely and efficiently delivered to a broad customer base. And while clean hydrogen is the future, it does not have a transportation network that supports this. Our proprietary technology stores hydrogen as a liquid that can be handled and transported no differently than gasoline. We do this using a patent-pending low-temperature chemical reactor and a liquid hydride material. We do not use compression, and we do not use cryogenics. This patented technology is key to enabling hydrogen-powered energy generation for a broad customer base. Our proprietary hydrogen storage system can store 2 to 6 times more energy than a lithium battery. The hydrogen is stored at room temperature and pressure with a smaller footprint than compressed hydrogen. And the process for storing and releasing the hydrogen is highly efficient. Why hydrogen? Clean hydrogen is the next clean fuel to decarbonize the energy market. Hydrogen is an alternative to solar for small footprint off-grid energy. And unlike solar, hydrogen is always available, regardless of the time of day, environment, or weather. Our energy as a service business model has multiple revenue streams, including installation fees, hardware rental and purchase, and reoccurring revenue from hydrogen sales and data management. Our target markets are California, Texas, Ontario, and BC, based on EV adoption rates, proximity to hydrogen, and grid stability. The distributed energy market is huge and growing fast. The total market size is estimated to be $250 billion, growing at a CAGR of 12 to 14%, and fuel cells are the largest segment in this market. Using the target markets only gives us a serviceable market size of $42 billion, and if we achieve a 20% penetration rate, that would give us a market of $8.5 billion. Our team is strong. I have over 20 years of experience in the energy service industry, and my co-founder and CTO, Brandy, has a PhD in chemistry, specifically in fuel cells. We are supported by teammates and advisors that have strong technical and corporate experience. We are building partnerships to de-risk our tech development, and that includes fuel cell and grid integration companies, engineering firms, and propane delivery companies. We've engaged with potential pilot partners, including municipalities for fleet management, utility companies for direct customer and demonstration opportunities, and property management companies for parking lot opportunities. We are supported by Mars Women in Clean Tech, Foresight Clean Tech Accelerator, Sheboot, and CTech West. Our hydrogen storage technology enables off-grid energy generation, and our competitors in this space include home generators, such as Generac. These systems run on emission-generating fuels. There are solar plus energy storage systems, such as Tesla's Powerwall. These rely on intermittent solar energy and have low storage capacity. And there's also a company from Australia called Lavo that uses solar panels to generate on-site hydrogen that is stored and used later with a fuel cell to generate energy. And that system is both expensive and also has a low storage capacity. An advantage of our technology over our competitors is the ability to provide DC to DC charging for EVs, which is a more efficient process. With our current technology roadmap, we will be developing and building our 10 kilowatt prototype in 2023, followed by pilot demonstrations with customers in 2024. Our first commercial sales begins in 2025. We aim to acquire 100,000 customers by 2030, which is less than 1% of our target market in 2030. Our total spend in the next 18 months is estimated to be $3.5 million. In addition to the raise, we are going to gain capital from paid pilots, grant funding, and strategic partner in-kind support. Today, we are raising $1 million with an equity raise. It'll give us an 18-month runway to deliver our prototype for pilot testing. Thank you very much for your time to be here, and thank you to the DEC for inviting us.
All right, I have a question on your total attainable market. What does that look like?
The attainable market?
Yes. So, so there is the total available market, total addressable market, and then there's the realistic attainable market based on your projections.
Yeah, so the 8.5 billion is if we have a 20% penetration into that serviceable market, and the serviceable market is just based on Texas, California, Ontario, and BC. Okay, so very briefly then, what is, just very generally, what is your plan to go into those markets? So very generally, we're going to start by looking for pre-sales and pre-customers, understanding who's interested. We'll use that interest to decide which city we're going to attack first. We're going to go into one key city in one of those places based on previous interest. And then we'll build a single hub for being able to, because it's a hub and spoke model, to be able to deliver our hydrogen to our customers. And then we'll grow based on where the market leads us in pre-sales and go from city to city and grow based on the market demand.
Excellent. Thank you, Natasha.
Yeah, so what we're really focused on is our hydrogen storage and release system, the reactor that does that. And we're working with multiple fuel cell companies to make sure that it can feed commercially available fuel cells. And so we're really focused on it being a product that can also be integrated or licensed to other potential people for fuel cell use.
Excellent. Thank you. Okay, a round of applause for all of our founders. Excellent job, guys. That was really good.
Thank you very much for inviting me to moderate the session. I'm quite excited about this. I've done a little bit of work in biogas and RNG, so I think it's fitting. So Ayrton, the floor is yours. I'll give it to you for 5 minutes.
Great. Well, thank you. And it's a real pleasure to be here today. Thanks for the invitation. I'd like to start by just giving you a little bit about how RNG fits into Shell's business. So like many others, Shell has a net zero emissions target of, well, by 2050. And so that means that we need to reduce our own emissions. It means we need to reduce emissions in operation and through our supply chain, our scope 1 and 2 emissions. But it also means, and probably more difficultly, if that's a word, it means that we need to reduce the carbon intensity of the fuel that we sell and the other energy products that we sell to our customers, our scope 3 emissions. Ambitious target, like many of us, we know this is a difficult task, but we do think it is achievable. And our framework for taking us there is called Powering Progress. So Powering Progress lays out really how we're going to transform our business, how we've started to transform and how we will continue to transform. You will see us investing in renewable energy and energy storage and in a variety of low carbon fuels, which include hydrogen, electric mobility, biofuels, and renewable natural gas. It also really pushes us to partner. And we are partnering really, across the spectrum. We're partnering with governments, with other industries, with customers and suppliers. And so moving on to, how Shell is participating in RNG. As John said, I lead the RNG team for Shell Canada. I've got a small team with me based in Calgary. I've also got a few people based in Houston, and they focus on projects primarily in the US. We're part of a larger global team that is developing projects in North America, in Asia, and in Europe. And we're supported by an even broader team. So experts in the biodomain, in engineering and technology, in marketing, and in road transportation. Our first project is called Junction City, and it is in Oregon. It is an RNG facility that is based on dairy manure and agricultural residues. And those residues are primarily gas and wheat straws. The RNG from that facility is injected directly into grid, so it goes into the gas pipeline like any other natural gas, and goes to customers. And the organic waste, the digestate as we call it, that's returned to fields through compost or through a fertilizer type product. We've got two other facilities under construction right now. We have Galloway in Kansas, and we have Bovarious in Idaho. And as you may be able to tell from the names, those are both fully dairy-focused facilities. They're co-located with dairies. And likewise, the gas from there will be destined to go to customers, actually transportation customers, given that this is dairy RNG. And the leftover organics, the digestate from there, will either go back to fields or it will be used as bedding for the cows. Now, we are looking at other opportunities. They're really too early stage to talk about, but I will say we're exploring feedstocks. So we're looking at wastewater treatment. We're looking at landfill gas as well, different types of animal manures, organic, like food waste, municipal solid waste, kind of your black bag, your green bag materials. And some of those are in Canada. But one thing that I would like to highlight is a memorandum of understanding that we signed here in Canada with Comtech Energy and with For Refuel. And that MOU is around building out fueling infrastructure. So building out compressed natural gas fueling infrastructure. And our aim is over time to begin supplying and finally displace the CNG, but to supply customers with RNG for CNG vehicles. And the intent there is to displace CNG for vehicle transportation. It's really important here. And I mean, you've touched on what are the biggest opportunities and what are the biggest challenges. So for me, this is very much a great circular economy story and a really valid one. We're taking waste feedstock that it will actually vent methane to your point in the introduction there. It will actually vent methane directly to atmosphere if we don't capture it. So we have the chance to capture that methane, to upgrade it into a fuel that we can use today as a low carbon fuel. And the waste from that can go back to farmers' fields and it can go back into the circle. And when these projects are done well, they bring really good benefits for everybody. For community, it helps to improve air quality at source because you don't actually have those emissions going straight to the air. In terms of challenges, I don't want to understate how difficult these projects can be to build. It is difficult to identify all of the feedstock that you need and to aggregate it and bring it together. And we saw a picture of Lethbridge biogas earlier, and I've spoken to the gentleman who developed that. It took years, and that is a hard-won project. So I have so much respect for what he did there. So not to understate those challenges, but I will say that for me, what I really see as a challenge, especially here in Canada, is that we don't have the same kind of mature and stable regulations that I see in the US. So if I look at the RFS, the Renewable Fuel Standard as an example, it's been in place for quite a long time. We're very clear on how we make money out of it. And it's not to say that the pricing has been stable over time. In fact, that pricing has bounced around significantly. It is, it is justified projects, it is killed projects, and all in the space of a few years. But we are very clear about how we can make money under that system. Likewise, with the low carbon fuel standard in California, it is very clear to us how we can monetize gas under that system. The regulations in Canada are really just coming into play specifically for transportation with the clean fuel regulation. But what concerns me a little bit as I see those coming out is that, at least at the outset, it might be difficult for gas to move as freely as it can do under the US system. And natural gas, to me, that is how natural gas moves. That is the business of natural gas. It moves around the continent. I think RNG should be able to do so as well, so that we can send it to the best market, and that best market could well be here in Canada, and it should well be here in Canada. And I just, like to close out on something that I touched on a little bit earlier. All of this for us, all of this really requires partnership and collaboration across the value chain. And I hope that out of these few days that I'll be able to meet a lot of you and understand how we can partner and collaborate together to bring some of these projects to fruition. Thank you.
Excellent. Thank you very much, Erin. That's a great overview. We're going to jump to our next panelist now. And keeping with the theme from this morning, we again have 50% of the panel with the same name. So John, I turn it over to you. If you could give us a sort of 5-minute overview of, why is Enbridge in this, right? You guys just moved the gas.
Good afternoon, everyone. Again, my name is John. Good to have you. I just want to say I'm so happy I went after Erin. She set the table. It's making my job a lot easier. So again, I'm from Enbridge Gas. I'm an RNG specialist working in the business development department, in which we house RNG, CNG, hydrogen, and carbon capture technology. And so I want to pause though for a second. My company's Enbridge Gas. So we have two names. Gas may not be the right word right now, but I didn't say what type of gas. It could be RNG, it could be hydrogen, or conventional. But I also want to focus on the name Enbridge. It's actually a merger of two words, energy bridge. So hence, I'm the distributor, and to my Alberta friends from last night, I'm the trucker. So with that, that's why I'm here today, is we try to deliver, and we want to deliver energy because life takes energy, and we want to be a part of that solution. We're not about answering no, we want to be solution engineers. And that's why we're here today, to talk about green energy, green engineering, and the opportunities such as RNG. When we talk about RNG opportunities, we look at it, and Erin set a great table. There's so many things that we can do. We take waste and we use it twice for useful work. To me, that's smart. That's working smarter. I would say I'm cost conscious. My wife would call me cheap, but I still say that's the best opportunity. Pay for something once and using it twice. And so within the opportunities for Ontario, with our team within Enbridge, we analyzed 50 opportunities last year. So our funnel bucket is 50-fold from last year. That was last year. The economy is still moving. We're doing project after project, doing investigations. We're looking at municipal. We're looking at green bin, landfill. And I wanted to pause just for a moment on the dairy or the livestock, because that is somewhat of a crux right now, because we have so much dairy for livestock in Ontario. Just unfortunately, it's off of pipeline. So we're working with the Canadian Biogas Association. We came up with a hub and spoke strategy so that we can bring that commodity either through a virtual pipeline, so trucking it, or until our pipeline gets there. So those are the opportunities that we're exploring now, because we see it as value, because again, we're bridging energy to the communities, and also to keep industry within Ontario. That's our inherent goal. Keep everyone here in Ontario, keep jobs in Ontario, and I want to be part of the solution. Now, you talked about some of the pitfalls right now with RNG. I would say it's policy. It's the permitting, the environmental permitting, the energy permitting, and the time lag as to when these permits get issued. It's not weeks, it's years. And that could postpone projects where the project dynamics change in that timeline. So you look at a downfall, I would most likely say permitting or policy under the preface of permitting is a struggle for us. And also education. You talked about RNG and you're like, well, what the heck is RNG? I asked that myself and I tried to tell my kids, and what made sense to me was you bring your banana peels home because that's fuel. But I had to dig a little deeper. You look at conventional natural gas and how we get to it. Well, we have to mine it or drill down. So it's geologic natural gas, which is sequestered. RNG is part of the natural carbon life cycle in our atmosphere. So it's already here, where conventional natural gas is incremental to our atmosphere. So that would be, education would be, right now, I'm trying to help change that narrative for people to say, oh, okay, I understand RNG, and now I know why it's meaningful and how RNG can be a part of one of the solutions to hitting our goals, which could be carbon capture, hydrogen, and electricity. The last opportunity, just to touch on, looking at the time, is that we're trying to decarbonize or electrify. What I do want to say is when you look at the O&M, so the cost constraints to operate your business, RNG is actually cheaper than electricity on your O&M, so your annual operating schedules. Then you also have to look at your capital outlay to convert from a natural gas piece of appliance to an electric appliance. So I wanted to leave that to say RNG does have its place in this atmosphere for us to get greener and moving forward. With that, thank you.
Enchanted Rock provides electrical resiliency as a fee-based service. We do that by designing, building, commissioning, operating behind-the-meter microgrids at commercial industrial type facilities. The prime mover that we're using is a natural gas reciprocating engine. And for folks that need true resiliency, you really do need a fuel if you need to be able to operate for days on end without the grid. Solar is great, storage is great, but for our customers like hospitals and data centers and major grocery stores, they want to continue on an uninterrupted basis. They don't want to curtail load. They want to operate the way they normally do. Our model is pretty interesting, and it's not even that unique anymore. We were the ones that pioneered this, but a lot of folks have followed. But we provide contingency capacity to that local resiliency customer, but also contingency capacity back to the electric grid. And it, we run maybe 2 to 3% of the hours a year, and that's typically where there's some type of instability around. It could be a shortfall in solar, it could be a bad net load curve, it could be just a sheer capacity shortage. It could be Winter Storm Uri in Texas. And so we're there to provide that emergency capacity back to the grid. Get paid to do that. Emergency capacity for our customer islanded from the grid when the grid's not available. We just use a good case study to describe our use of RNG. So Aaron's put it in the pipe and John's kind of brought it to me theoretically. And we have a deal with Microsoft. It's in San Jose, California, and they were planning on, it's a big data center. Their cloud business is still growing pretty rapidly. They were planning on using 23 megawatt diesels at this facility in San Jose. And just as you can imagine, a lot of pushback in Silicon Valley on using diesel, even the cleaner tier 4 diesel. And so they had a desire to basically still have the same level of resiliency, but number one, have ultra low local emissions when they ran. Number two, have it fully decarbonized. And so what we did is we actually are the only company with a natural gas reciprocating engine that's qualified for the California Air Resources Board, what they call distributed generation emissions limits. It's ultra low emissions, even tier 4 is almost an order of magnitude higher. So we achieved that again through our natural gas generation, and it's using pipeline gas. But it's being directly offset with RNG. Now, think about it from the perspective of, we don't really know when we're going to run, if there's a power outage or at that specific facility. Likewise, we don't know when we're going to get a call from, in this case, PG&E to turn on an emergency condition. It's an emergency EA2 event right before rolling blackouts. We don't really know when that will happen. So it is very intermittent use. We also have maintenance runs, but we know on average about what we consume in a year. On the other hand of the supply chain, the RNG facility has to operate on a continuous basis. So we basically are balancing that out. And where we true up on an annual basis, it's a book and claim program. So we go out and we contract on a 10 or 15-year basis. We're pretty good offtake. Our revenue from the grid is actually a good program for us, and it makes us a lot less price sensitive. So we're not doing this as 8760 energy. It's just contingency. And so when we run, we get paid well. And so we can afford to pay the current price of RNG. We'd like to see that come down over time, obviously, but we're very good customers because we're long-term offtake and we can pay those prices. So that long-term offtake, again, the continuous production helps finance a new facility. So you get additionality. And again, where there's a direct offset on an MMBTU basis for all the pipeline natural gas we consume, that's directly offset with the RNG production that's injected into the pipeline. And it really is fungible because that RNG is pipeline gas. It doesn't matter if I'm not consuming that molecule directly, somebody else is. And again, the CI is now depending on the actual mix of the RNG we're buying. We have a requirement to be CI less than 0, but we will always be carbon neutral to negative. As far as the biggest challenges, there's still a kind of what I would say is a perception, misconception, and like this is some kind of second-class citizen with regards to climate change, and I don't quite understand it, and because methane is an incredibly potent greenhouse gas, right? Especially in the very short term in our lifetime, and so we need to capture it, and so we see it in a lot of places where you have to be some type of renewable to participate in this type of electricity grid program. We had to go through a lot with the California Public Utility Commission just to qualify to participate in this program. Now we can, but that's probably one of the biggest challenges. As far as the opportunities, we think, I mean, we're seeing a tremendous amount of demand, specifically from data centers right now, both directly from the cloud guys and indirectly through the colos, because it's the group that you would think of. It's the Microsofts and Metas of the world that have the corporate mandates to do this. So we're seeing a lot of demand for this type of RNG use. And we're very excited about being able to provide fully decarbonized, ultra low local emissions, true resiliency to our customers.
You know, we do see that there is room to grow, and the Canadian Biogas Association has put out a report fairly recently that actually describes this in real numbers and petajoules and so forth. So we do see that there is room to grow, but I will say, you know, in terms of scale, to us, this really will not reach the scale of, say, advanced biofuels. It is not going to take over from fossil natural gas. It really just isn't. But it doesn't mean that it isn't worth doing. There is still a lot out there. It is still worth capturing those emissions. Like I said, there's an immediate use for it, but we see going forward, it can also transition into being a feedstock for hydrogen. Just all around, there is still a lot to be done. There is still a lot of waste. One of the nice things about this business is that we don't stop making waste. We don't stop putting stuff into landfill and compost and so forth. And maybe just briefly on that food versus fuel debate, I think very clearly, especially in RNG, it does not make sense. We should not be using energy crops as fuel for RNG. There's plenty of, you know, straws, there's plenty of residues, but that is not the right thing as stock for RNG.
You know, we don't live off of air and light. There's always going to be waste. It's going to be steady stream of waste. Just the only opportunity or diminished opportunity is that volume. But it's still a great idea because we're not being wasteful. We're using something twice and putting that second option to useful work. And you look at the size of opportunities. So Enbridge just put a filing in front of the OEB on Halloween. I don't know if it's an omen of some sort, but that was the actual day in which we are making the proposition to green our pipeline by 4% volumetrically. So by 2028, 4% will turn out to be 21 PJs, which is a ton of gas. So there is the appetite, and we're looking more and more at injection points to take the dairy farmers that are off pipeline to reduce that amount of time on the virtual pipeline or the trucking opportunity. So we're looking at that across of Ontario, and I'm involved in quite a few investigative opportunities to say, we have a cluster of farmers here. How can I bring them to market and reduce that transport time? So the opportunity is there, absolutely. Is it a great lever? It is, because now we're changing from conventional to RNG. And people, when you look at, say, the academics, universities and colleges in which they have to meet our mandates, can be an easier solution because it's an O&M bucket as opposed to capital bucket. Unfortunately, we came out of COVID, the universities are strapped for cash. They've taken losses on their ancillaries because no one was there. So capital is hard to come by. But if you reframe the question and say, well, let's access the O&M and let's change our source of energy from conventional to RNG. Yes, there's a premium above conventional, but still cheaper than electricity. You're now meeting or accelerating the reduction of GHG targets. So opportunity, huge. Supply and demand, the supply is not there. So if you're going to buy it now on a long strip. Get in there because we're continually trying to open our markets throughout Ontario and bringing gas from the States through our Dawn hub, moving gas from Vermont to New Hampshire to bring RNG up to the north, as opposed from Ontario going to Fortis, BC and Energy Quebec. So with that, I'd like to pass over to my colleague.
Sure. It's interesting. It's always the first question that everybody asks, is there enough? And I kind of default to what you said, Aaron. Well, it really, I'm not sure if it matters. It's like we should still be capturing this methane, and then the next question, enough for what? And like, are we trying to convert the entire natural gas system over to renewable natural gas? I don't think so. And so I don't know why that hurdle is always placed in front of RNG, but regardless, from our perspective, I guess there's a couple things. One, as I mentioned, we're really, really low capacity factor. So I mean, I could do 30,000 megawatts of data centers and barely move the RNG market because we only run, again, 100 in California, maybe 50 hours a year. And so we really don't need that much. But we can provide tremendous price support for the supply side on large sites, very low run hours. The second thing is that I don't know, I've been around these markets for a while, and it just seems like price, like the current prices will drive investment, and we'll find new ways to produce RNG and gather it and distribute it. If it follows anything like some of the cost curves that we saw when we had a lot of deregulation in natural gas in the 70s and 80s, you're going to start with these very high prices that drive investment. You'll see a lot of new supply, which will bring prices down, and we'll keep investing. So I don't think any of us really know, but I know that there, as you mentioned, John, there's just a lot of waste, and we that as humans and animals and everything else produce this waste, and it seems like if you kind of look at that from just a proportional perspective, there's a lot of untapped methane capture. And we don't necessarily need to answer the question now. We just need to get started, and I think the current pricing provides an incentive to do that.
Overall, I'd say not a huge infrastructure deficit. I mean, certainly there are some places that are stranded assets. But virtual pipeline is actually quite a common thing that we see in RNG projects. So where, a landfill is out in the middle of nowhere, it's quite common to move that gas via truck. I think perhaps where there is more of an infrastructure deficit is on the compressed natural gas, the transportation side of it. So actually filling vehicles and having vehicles themselves.
Just one item to bring. I look at RNG and you say we talk about off pipeline. Okay, that's great. Now we can go into more remote areas and aggregate that hub a little further than my traditional pipeline to service more people, say in the further north. Say now I don't have to lay a high pressure pipeline, a 12-inch 1632. I can have an independent hub and spoke in which it's an island of RNG, where instead of the farmers bringing in their valuable RNG to my pipeline, they start a bigger node, a city, and bring it that way. So now we have an avoidance where I don't have to lay kilometers, 30, 50, 100 kilometers of pipeline. So it's another tactic to bring value to the people of Ontario.
So I actually think it's the opposite of an infrastructure deficit, right? You have the entire natural gas grid, and whereas we're all looking at different ways to blend hydrogen into that natural gas grid. It's built, right? So you have the opposite. You have a surplus compared to a lot of other technologies. Obviously, as you're pointing out, John, there's different ways to think about gathering. I think obviously there's investment in the processing, but from an infrastructure perspective, it seems like it's kind of that arb between transport and gathering and how that plays out. From our perspective, we'd rather see all RNG go into the pipe and then kind of out the pipe for electric generation, because we think that's kind of that's helpful to us as a business, obviously, but we think that's kind of the lowest carbon intensity path. And so, and then you take advantage of, again, both the gas grid and the electric grid. I mean, it really is. It's fully decarbonized resiliency from the standpoint of what Microsoft is looking for to get other data centers that we're in current discussions with. Again, they want the lowest emissions possible. They understand there's going to be some emissions to be able to run for however many days the power is not there, but they want it fully decarbonized. And so it's a corporate mandate. So.
Sure. So for us, we are a regulated party in Canada and in the US, which means that we sell fuel. And so that we need to reduce the carbon of our fuel. So it's very clear to us how we can do that with RNG in California, in the US, and in British Columbia as well. With the clean fuel regulation that's coming out in Canada, it's a little bit less clear right now. So we think that there is an opportunity here. We think that RNG can help us there, but how it will happen, those kinds of things are still being developed. And so when I said in my introduction that I hope that, Canada doesn't make it more difficult for us to meet those regulations here versus US, this is really what I'm referring to. We would like to be able to produce and sell renewable natural gas as a transportation fuel and generate credits in a similar way.
John?
For us, for Enbridge Gas, I would come back again with policy. The timeliness of execution. It's hindering us from getting RNG into the market quicker and getting to the people that need it to be more competitive and to stay in Ontario. And also on policy for the governments to let Enbridge Gas green our pipeline. It's been years. Fortis, BC, and Energy have been, they've been picking the pocket of Ontario and buying up all the RNG in Ontario and shipping the attributes back to BC and Quebec. So that would be my two under one umbrella. Would be policy, would be the timeliness to get the construction done, get the approvals, the permitting, and then the lead to constructs to build pipelines if need be. And then also to allow us as a company to green our pipeline to, again, bring the value to our customers.
Thomas, anything from your end?
I mean,
What would be on your wish list?
Just a continuation of what I mentioned earlier, which is just having RNG on equal footing with solar and wind and whatever the program is. So whether it's like we mentioned a second ago, participation in the grid program, tax incentives, whatever it might be. And it right now it just generally isn't. There's a lot of ground to plow.
It comes down to cost when you're doing that further refining. And we're looking at other topics. Earlier this year, we were looking at going from syngas to hydrogen and then RNG, whatever kind of combination. But it started off with the syngas and the biogas. A lot of it's cost competitiveness. And when you looked at the switching point between taking biogas and creating an electron or taking it one step further to RNG, you're looking at the value of the commodity. I'm dealing with some customers that are getting off their IESO contracts to provide the electron. They're going to exit out and start making RNG because it's more competitive and they're diversifying their business, looking at the financials.
I make the case that you really shouldn't use RNG to make hydrogen. You're already way negative CI depending on the source, right? So you don't necessarily need to go more negative CI. Number one. Number two, one of the biggest benefits of RNG is you can use it in the existing infrastructure, whether it's a burner tip application or combustion application or a feedstock. And so it seems like it's high. RNG's highest value is just kind of a direct replacement for pipeline gas. Just to be clear, whether we're burning RNG or natural gas, it is methane. It's CH4, right? And so we're taking that, we're combusting that in the engine, and at that level we're indifferent. So it really does come down to the attributes and what that means. And from our perspective, like the Microsoft example, it allows us to access markets that we couldn't with just natural gas because we have a carbon intensity of 0 or less, which although the RNG costs more, the net cost to the customer is less because our run hours are so low. So if I run 100 hours a year paying $25 an MMBTU for commodity transport and attribute, it's really not that big a deal because I'm getting paid either in some capacity payment or a very high energy price or some combination of both. And so the net cost, in the Microsoft example, the net cost actually went down through using RNG versus natural gas. That is kind of the value proposition, is access to those programs. Again, from a regulatory perspective, the more programs like that we can access, the more demand there will be for RNG just for that reason. So it really is an economic more than a physics type or anything else, an economic benefit, which helps more microgrids get deployed.
Thank you. So my team is probably sick of me saying this, but actually my favorite part about RNG is that it works today. There are no big,
Yes.
commercial technology things that need to change. There are incremental improvements for sure. There are ways to drive the cost down and so forth, but we can take waste today and make gas out of it and make fuel out of it. And I think that is just the best part. Thanks.
Okay, John.
Springboard off that, I'd like to say I love it because there is no technology change. It is equivalent to conventional natural gas. You don't have to change your equipment, your burner tips, the pipeline, the pressures, nothing changes. It's just that source of where it's coming from. So it's beautiful. You don't need to do anything. It's there, it's apparent. Let's use it.
I'm going to build up what both you guys said. I really don't see or need any big, huge technological advancement for this to succeed. I haven't done the numbers, and I probably need to before I just start spouting off. But it seems like for per CO2 equivalent is probably one of the cheapest forms of decarbonization out there, and you can do it today. So I mean, I think hydrogen might be great someday if we figure out how to get it to where it needs to go. But what about the time in between when you could have been decarbonizing, right? There's that time function that while you're waiting for great, you pass the good and you didn't get done what you should have got done on a kind of a net basis.
And last but not least, we are here today at the Decentralized Energy Forum. We have a great array of speakers that are going to talk to us about how industry gets it done. So how can industry get to net zero? As passionate as I am about the hydrogen sector, I go back to the point that the path to net zero includes many tools and requires many creative approaches. And some of these tools and approaches are the ones that we are going to be discussing today with these fantastic panelists.
Thank you. So I'll start off with we've signaled to the world that we have this problem, and industry is a large market with respect to decarbonization. We've been helping a lot of industries in the metals, mining, oil and gas sector to help with looking at different technologies to support them with their decarbonization efforts. I think the largest aspect that we've seen globally through many of our clients that we've interfaced with, and these are large blue chip companies, large petrochemical companies across the world, has been the need for alignment and coordination. My role that Yvette introduced me as a business development, but by heart, I'm a project manager, and execution in that project certainty is very important to private industry. And getting the governments and industry norms and as well as community members aligned is strategic to being successful. And that's part of de-risking a lot of the projects that will be coming up in the next decade and the next 2 or 3 decades as well. And part of that is making sure that the community community and stakeholders buy in, but also that the regulatory agencies have the tools and the capacity to furnish these projects and make sure that these projects are successful. I think a lot of the private industry are lean on a lot of EPCM vendors and EPC vendors to do good in terms of execution, but it's that initial hump of actually de-risking a project and having some of that project certainty and signaling to the market that there is a lower risk to deploying some of these technologies. My background has been in oil and gas and also in nuclear, and in oil and gas, it's been speed to market. When I worked at Suncor Energy, riding out those commodity cycles has been very, very important. And you want a deployable solution so that you can earn your revenue. Nuclear is very different. It takes a little bit longer to put a project in place, and you got regulatory hurdles and stakeholders that you have to satisfy too as well. So there's two different extremes, and there's what I'm trying to get at is basically there is not one solution or one Rosetta Stone, I guess, to industry. There are many solutions. Hydrogen being one, could be solar and wind, can be another one. Nuclear has been one of the topics that have been starting to pop up in the last little bit, especially with some of the IRA incentives that have been down the States, and just recently some of the incentives that have been brought here in Canada. And a lot of the companies are looking at both fusion and fission nuclear to help with decarbonizing their operations. That's small and large scale too as well. But then from that, there's all opportunities to mix that energy with renewables, solar and wind, hydro, and so forth. And so basically, again, make sure that business case is sound and that you have that plan in place to de-risk your deployment from an industry standpoint is what has been really on the top of minds of a lot of the industry players that at least I deal with.
I work with Arcus Power, and we interface with many different industries. So we get information about the different processes across the board. But to take a step back, I just wanted to explain it in a different way of what we do. And I'm going to start off with my phone. And if you're like me today, I've been looking at my phone off and on all day. And by 8 o'clock tonight, it's probably going to be out of batteries, and I'm going to have to plug it in and charge it. And it's going to take a couple hours to charge up, and then I'm good to go again for tomorrow. But if it's a weekend and I'm out in the mountains and I'm hiking and my phone's in my pocket, I can usually get 2 or 3 days of a charge out of my phone. And as a, I guess, environmentally conscious person, I need to make a decision on what actions I can take to have an impact on my energy consumption. So face value, I should not touch my phone as often. But then the other day, my kids picked it up and they started counting my apps. And there's 53 apps on my phone, and everything from my banking to my photo management to everything I do, like transit passes are on my phone. And it got me thinking, and basically my energy consumption isn't related to how often I pick up my phone. It's actually related to all those apps that are on my phone and the data centers that are crunching all the data to support my app use on my phone. So for me, if I actually want to have an impact on my energy consumption related to this device, I have to delete all of my social media accounts and delete all my banking apps and sort of reduce what I'm doing on it. And so what this does is illustrates that I have to have awareness and visibility into the full picture of my energy consumption to be able to make an actionable change in my behavior. And that's what we do as a tech company with all these different industries, is that we give them visibility and awareness into their full energy costs, all the electricity that they're using. And then we take it one step further and we help them make decisions on their behaviors and which behaviors they can actually bring into play and action on to make a big difference on energy consumption. And so big picture is that they need to have that full visibility of all the different layers that are feeding into the consumption. And part of that is the carbon intensity of the power that they're consuming, or the cost of not only the cool price, but also the demand charges that are backed up behind them, or how does that play into the other costs of monetizing their load in different markets, like demand response. So together we work with our industry partners and offer an optimized solution that all comes down to what drives them, which is the economic benefit of reducing their electricity costs.
We are a carbon accounting and carbon management company delivering a software tool, and I'll talk more about that in a moment. But the thesis is you can't change what you can't measure, right? And how do you identify solutions? And the backstory of how this came to be, I think, is as important as to what we're doing going forward. So prior to this, I worked for a large data center provider. and it helped oversee our transition to 100% renewable energy. And I'll use air quotes for 100% renewable energy for those who will appreciate that. And we deployed over $1 billion of power purchase agreements. We actually broke ground on the largest behind the meter, and I don't know if it's still the case now, but at the time, solar plus storage project of 100 megawatts of solar plus 100 megawatt hours of storage behind the meter in Nevada. Helped develop green tariffs in Michigan and worked all around the world. And in 2017, Greenpeace gave us straight A's in the data center industry, ahead of Google and Meta and Apple. It was a great day, except we kind of stopped and we said, how green are we? Are we actually as green as we think we are? Because we have these recs. We've done additional and local projects. We've been innovative. Then I had the realization we may have deployed $1 billion without fully understanding the impact of what that actually means for us on decarbonizing. And so it started with the idea of how can we build 24/7 grid emissions factors that are dynamic, that take into account what's happening on the grid, what's happening off the grid, and using not a marginal analysis, but an emissions average analysis, try to avoid some double accounting. And I know we can have a whole debate about that later. But the idea being is how do we develop those that granular level of data so that people can make operational decisions, so people can make capital decisions. And how do we match that up to their load consumption? And then we said, how do we expand beyond just electricity and look more broadly, everything from natural gas usage, refrigerants, vehicle telemetry data, and getting as granular as we can, and ultimately building a very comprehensive platform that today looks enterprise-wide at organizations and is tracking their emissions as the data is created. So that is from 15-minute AMI meter reads to vehicle telemetry data that's tracking idle time and everything in between, and matching those up with emissions factor data that not only helps with reporting and compliance, which is becoming more and more important, but is letting people to actually make decisions, right? To understand what part of their loads they can decentralize and what that impact is, both from an environmental perspective as well as from a cost perspective. And now you can layer on top additional things such as the IRA tax credits in the US. And we were just talking about this, just listening to a podcast with Justin Trudeau talking about how Canada is going to come back over the top with more incentives, right? Because this data matters, right? This data is driving decisions. This is about how we get businesses and aligning those incentives to move this forward. And we work with customers from most of the entire Las Vegas Strip to state governments. We're taking on some of our first federal governments. We're working with telecommunications providers and continuing to expand, because ultimately what is so exciting for me, and I grabbed the Nick earlier, is in 2019 when I spoke in Calgary, the idea of decentralized energy kind of felt like this snowflake of an idea, or it felt very out there. And today everybody is trying to say, what can I put inside my graph? What can I take ownership of? What can I have control of? And now we're lining a bunch of tax incentives to do just that. And I think it's a really exciting time, and we hope that the data we're providing and we have automated insights engines and other tools is helping to accelerate people's transition to net zero and putting this forward.
One of the things we've unpacked in a recent study with the government of Canada was looking at coordination across the provinces, and this could be super true as well in the States as well. But looking at sort of from a supply chain standpoint, enabling those best athletes in different areas of Canada to leverage those expertise to support carbon capture, to support nuclear and renewables. There's a lot of diverse manufacturers, labor bodies and so forth like that can certainly help us with respect to the capacity crunch that we're facing as sort of the industry too as well. That's one aspect too as well. And the second aspect, which might have been changed with the fall economic statement, where they've been pumping some fresh dollars into some of the regulatory bodies. A lot of that is going to be sort of your critical path to some of these deployments, regardless of technology. And that is going to be really important regionally and federally, provincially, state, to support the decarbonization efforts for any industry.
Optimistic opinion is that we are accelerating. So year over year, we're going to get faster and faster, and these adoptions are going to come quickly. We still need a lot of support in place, but from where we were 10 years ago, I come from a background in oil and gas and E&P companies, and this was nowhere on the radar 10 years ago. And now, you know, transitioning from oil and gas extraction, now I'm on the other end of it for delivering electricity. Yeah, the conversations and the customers, we work with E&P companies, it's so different now, and I do feel that it's accelerating, and I'm optimistic about that.
I agree. I think it is accelerating. I think we've almost started to reach like a terminal velocity where there's no going back, right? I felt like in the, you know, green tech 1.0, we definitely took a step backward, but right now we've kind of gotten there. And I think it starts with market demand, right? Is that consumers want this. We talk about, like, we work with hotel customers, and now conventions as part of their RFPs are requiring, tell us what your carbon footprint is and what you're doing to mitigate that. We see this with our customers we're working with who are doing ethanol and biofuel production. We're saying, hey, we need to track this because tax incentives are tying to this. So as the markets keep pushing, and the $1 out of every $3 in the United States it's in the capital markets is tied to an ESG fund, right? So 33% of all capital in the US is tied to something that has sustainability. So that's moving it forward. But I think that picking up on this, the other thing we need to do if we want to accelerate this, because we're still not going fast enough. I think that's kind of the preliminary takeaway from COP27 is you think you're going fast, we're going slow. We've got to go faster, right? The rain in Greenland last month and what the devastating impacts of that are. I mean, we're seeing this. I think it comes down to the regulatory piece, what Mario was talking about. We've got to cut this regulatory red tape. I love that we're putting all these incentives out there, but you know, the first nuclear power plant built in the United States in the last 40 years, Project Vogel down in Georgia or South Carolina, Georgia, to feed the Southeast, it's going $20 billion or $15 billion over budget, and it's taking an extra 9 years because of regulatory pressure. We have incredible technology that's coming out with microreactors, with hydrogen fuel, with even with solar and wind, where we now have regulation because people don't, you know, the NIMBYs, the not in my backyard people who don't want it there. And that affects decentralized tools too, right? You want to do something on your own site and take ownership of it. Now you have to make sure that you get the regulatory approval to do this. We need to fast track that in the US, in Canada, in Europe, because we're committed to it. We need to fast track this to make that happen. I think that's the last piece. And because that's the one that people have to visually see. It always seems to be the last one to get addressed, but it's an important piece of this equation.
Definitely agree.
The tools we have, and we do this with our public sector customers, we're doing this more with private sector, is actually sharing data, showing how engagement actually, you know, and how, you know, the immediacy of results. People don't want to see that I did a project and then a year or two later I can see the results. They want to see results. There's kind of an immediate gratification, but communicating and creating that engagement with the public, with customers, is such an important piece of where I think data fits into this. And one of the areas where it's not just to help, you know, when we think about this from our business, is like, it's not just about helping customers to create, you know, the regulatory compliance and to decarbonize. It's how do they use this data to create value into their business? How does this create competitive advantage? How do they drive the values so people want to do this, so that their team members want to be part of this, because it's creating enterprise value for an organization by doing the right thing, because customers want it, because investors want it, because it delivers that value.
From the voice of the capitalist here, I just simply want to add a couple of points. And so I wholeheartedly agree that we need to revisit the whole regulatory framework, from comparing that to other regulatory frameworks, and just put a lens at speed to market. And then that's been touched upon by the panel, and thank you for saying that. We like to think that in Canada, we are leading the world in many ways. I don't think we are. I think there are other markets that are developing some incredible technologies, and they're going to market a lot quicker than we are. And so we have no way of baselining or competitive perceived advantage that we have. And I think it comes back to the analysis paralysis that exists within the regulatory frameworks that pause otherwise large amounts of capital that is sitting on the sidelines wanting to invest in these types of technology. I'll tell you right now, in the province of Alberta, there's about $2.5 billion of investable capital that is sitting on the sidelines that wants to invest in alternative energy, but it isn't. Why? Because the return of investment and speed to market that are keeping that from happening. So this is a bit of a wake-up call to all of our policy folks that if we don't act now, we will fall behind.
With some of the other parts of the regulation we're looking at, as you talk about more, and these decarbonization schemes or plans, and these net zero plans the country set out there, it's net of what? And if you want to create that engagement at the different levels, you still need to have that data to underpin and to drive this policy decisions, which is a lot easier in those smaller countries. It's a lot easier given different forms of government. I would argue inversely that kind of the chaos that's created from provinces and from municipal governments actually is to the advantage, because it allows, there's certain communities, and we see this in the United States, right, where there's certain communities that are being very progressive and moving this forward, regardless of the outcome of a federal election. And that helps to keep the market moving, and businesses who are doing businesses in multiple jurisdictions have to comply by whatever jurisdiction has the highest regulation. So you still are able to advance this progress, but at the end of the day, it comes down to data, right? You still have to have the data to report to a regulator. You still have to have the data to make a decision. You still have to have the data to understand where on the journey anybody is. And I think, the only absolute data we seem to have today is, particles per million that seem to be in the air into what the impact is. We're still struggling to agree on what the, environmental impact is of an internal combustion engine or of a diesel generator or something else. But it's data that will create this alignment. And I think that's the gap that, a number of us here, that we're trying to solve.
Number one driver for the customers we work with is the cost, and it all comes back to the economics of the electricity that they're using, or the power that they're using, or the energy they're using. And so the conversation always comes back to that. But what's different now is that there's a cost on the carbon that they are incorporating. And I was in a meeting just earlier this week, and they mapped out what the carbon cost was going to be for their facility over the next 5 years, and it was going to probably double or triple. And all of a sudden, it's at a magnitude that they have to act on it, and that will drive their mandate to action some of these new projects. I would say that it's finding a sustainable funding model and incorporating sort of the focus on green funding and accountability to deliver on what you say you are going to achieve. So it's not just you have to be able to measure and achieve in order to ensure the funding continues.
Building off the last question, I think that we actually do need to start bringing in some sticks, right? We do need to have a price for carbon, and we need to tie this to tariffs of imported goods that are coming from actors in other countries that aren't following these same rules. And we need to hold ourselves to those standards, and then that onus on our policymakers to keep incentivizing our companies to decarbonize and move things forward is even more poignant. So I think it's time to start bringing out some of the sticks, if you will.
Bring out the sticks. Good. Mario.
I think it's incentivizing industry and governments to work more collaboratively, and instead of in silos. I think I think we're getting better at it. I think they're soliciting a lot of input from industry, but I think it's incentivizing that discussion to move forward a lot better.
Okay, thanks everyone.